Okay, now let us consider the algorithm for a sum of subset problem. So this is an algorithm. So here mainly you are having two functions. One is the if promising and other one is this sum of subset algorithm. So the parameter what you are passing here is the I represent the index, and the weight is nothing but the current sum what you are having. So for example, if I will take this particular problem, this 1 represent the weight, this 4 represent the weight, current sum what you are having, 3 represent the weight, 4 represent the weight, 0 represent the weight. So that is nothing but, and this 0 represent the weight. So that is nothing but the weight and the total. So one more parameter is the total. Initially this total will be the sum of all the elements. So total here initially how much it is? The sum of all these elements, that is how much it is? 8. Okay, in this problem it is 8, like that. Okay, so these are the three parameter what you are having. So one is the index I, other one is the weight, that is the current sum, currently what you are having, the sum, and the total is initially the sum of all the element, and then it will go on decrement. So for example, in this particular case, initially total will be 8. Now after adding with 1, the total will be now 7. Now total will be 7 minus 3, that is 4, like that. It will go on decrement whenever you will be considering the any of the element. So that is an total. So now that is input output purpose, you go through that one. Now if promising, I am calling the function if promising. What is by passing the same parameter, index, weight and the total. So what is this promising function will do? So the promising function will give you the information about whether to continue or to stop. Whether to continue or to stop means that, so whether I have to continue with left branch and right branch, or I need to stop here only. Here I have not continued, here I have not continued, here I have not continued. So that is what this promising function will tell us, whether I need to go for a left and right branch or I need to stop. Means it will indicate whether it is a dead vertex or it is not a dead vertex. So that is what the promising function will do. What is there in this promising means, here you are having two function, one this and this one. So one more bracket is missing, you put the bracket here and one more bracket here. Okay. So return, so weight is nothing but a current sum plus total. If it is greater than D, the current sum plus the total, if it is greater than D. Okay. So and one more condition is the weight is equal to D. When weight will be usually equal to D, when we will be getting the solution at that time, and weight plus the sum of the S of another next element if it is less than. You remember this, what is this and what is this? So I told you, the dead vertices, when the dead vertices will occur. If the weight and the next element addition, if it is greater than D, that is a dead vertex. So this one, usually this I told you, so when there is a dead vertex. And one more I told you for last example, this one. Here only 3 elements are there. This one. See here, that is 0 plus 7, which is less than D. The second dead vertex. 0 plus the next element. Current sum is 0. The next element is less than D. So that is what that we have written in the promising function. So the two cases I told you, to get the dead vertices, that is what we have written. It is current weight, that is current sum plus including the next element is if it is less than D, and the one more dead vertex condition I told you, current weight plus the total if it is greater than D. So these two are the cases for the dead vertices. And what is this one? When we are getting the solution. Okay, these are the 3 condition what you are having in this promising. Okay, now this promising will if it is returning the 1, then continue. If it is returning 0, then don't continue, means it is a dead vertex. So if it is 1, means continue. So in the continue, I have to check that whether it is a solution or not. Initially, I need to check whether it is a solution or not. If it is a solution, then print them. See here, what we are doing, if we are getting a solution, I need to print them, no? So if I am getting a solution, I need to print 1 and 3. I need to print 1 and 3. Here, if I am getting a solution, I need to print the 4. So that is what we are doing. If the weight is equal to D, weight means the current sum is equal to the D, then we got the solution. Therefore, you print that what are the element you have selected in the given set in order to find the solution vector. So that you write it. Otherwise, what I have to do? Otherwise means the other situations. So if it is not, if it is a solution, stop there. If it is not a solution like this, then what I have to do? Left call, right call. Here also not a solution. Left call, right call. Here also it is not a solution. Left call, right call. So that we have to do. Again for left branch and right branch, I have to call the sum of the subset. So that is what this else. So if it is a solution, print the result. Otherwise, you go for a left branch and you go for the right branch. The first two instructions are for the left branch and the next two instructions are for the right branch. Okay. So what we are doing when I'll move towards the left, what we are doing when we are move towards the right. So that I'll explain you. So when I am moving towards the left, what is happening? The index will be an incremented by 1. Index will be incremented by 1, 0 to 1, I plus 1. And what about the current sum? It is nothing but when I will move towards the left, this 1 will be included here. Okay. So when I will move towards the left, what is happening? Index is incremented by 1 and your current sum, that is the weight, will be incremented with whatever you are written here. So with 1 or with 3 means it will be 3 like that. So it is 1 with 1, no, because first element is 1, so it is 1. And what is this total will become? It is nothing but this minus this. So it is 7. So when I will move towards the left side, what is happening? Index will be incremented by 1. So 1 will become 2 and weight will be this plus this 4. So it should be 4. By mistake I have written here 2, it should be 4. So it is 2, 4, 4. Sum of subset of 2, 4, 4. Now what is this total? This minus this, it is 4. Getting my point? So when I will move towards the right, what should happen? So index will be incremented by 1. So but here it is without this, no? The sum will be, that is weight will be as it is, current weight will be, or current sum will be as it is, 0 only. And what about a total? Total anyhow, whether I am considering this first element or without a first element, but anyhow I have considered it, it is already over. Whether it is with or without, already we have considered it. So remaining total will be only this much, 3 plus 4, 7. So it is 8 minus 1, 7. Here also it is 8 minus 1, 7. Here also it is 8 minus 1. Index here also it is incremented. Index here also it is incremented. Only the difference between left branch and right branch is, so in case of the left branch, this sum will be taken. That is 0 plus 1. But here it is whatever parent is there, current sum, that will be carried out. Same 0 will be carried out. Here it is 0 plus 1, 7. Got it. So that is when we will be calling the right branch. So here you can observe for left how it is working. So left index will be incremented by 1. So it has become 2. And what is your weight? It is 0 plus 3, 3 and 7 minus 3, 4 total. When I will move towards the right branch, index is incremented by 1. Weight will be same, parent, because it is without. Then total is 7 minus 3, 4. Because whether it is a with or without, anyhow we have considered that element. So it will be 7 only. It will be 4 only. Here it is 2, 0, 4. it is 2, 3, 4. So that is how when I'll move towards the left and when I'll move towards the right, that is what is happening. See here, first two are for the left and see here, sum of subset, how it will change. Index is incremented by 1. Weight, current sum is current sum plus the next element. Total will be total minus next element for left branch. For right branch, again same thing, index will be incremented by 1. So weight will be parent weight only. You don't add the next element, okay, when it is a right branch. Anyhow, total will be same. Whether it is with or without, the total has to be an decremented. So index is same. This is total is also same. Only the difference in the right and the left branch is this weight. So for the left branch, it is with the next element. It is without a next element. So now what is this solution of I plus 1 is 1. Solution of an I minus 1. So when I will move towards a left branch, it is 1. When I will move towards a right branch, it is 0. So what is this one is, see here, when the weight is equal to D, means when we are getting the final solution, I need to print the element. So when I am printing the element, if it is with, then 1. If it is 1, then only I am printing in the final solution vector. So if it is a without, right means what? Without. So without means then I will make that solution vector for that particular element is 0. Means that element is not selected. So if it is 1, then only I am printing. If it is equal to 0, I am not printing in the final solution vector. So in order to print the result, so we are considering the solution of I plus 1 as a 1 if it is a left branch, and I plus 1 is 0 if it is a right branch, because only if I am moving towards the left branch I am considering that element and it has to be printed in the solution vector. If I am moving towards the right, then I am not supposed to take that one. So that will not be printed in the result. So finally this is your algorithm. Got it? So promising will tell you whether to continue or not to continue. If it is yes means continue. When I want to continue, I want to check whether final solution I got it or not. If I am getting the final solution, then print the result. If I am not getting the final solution, then move towards the left and move towards the right branch. So these two are for the left branch and these two are for the right branch. Only the difference in the left and the right branch is this one. Current sum is current sum plus the next element. Here whatever the parent current sum was there, the same thing will be carried out. Now how this will be implemented by using an stack. I think all of you got this one, how to write this one. So initially what will be pushed on to the stack, all of you know that when you are using when you will be using the recursive call, you will use an stack data structure in order to implement that one. So that is what I have done here. So initially 008 will be pushed on to the stack. I'll call 008. So when I'll call the 008, what I'll do, I'll call the promising. So when I'm executing the promising, so it is what is that, weight plus total. What is my weight? It is nothing but 0. Weight is 0 plus total is the sum of all these elements initially. So it is 8. Is it is greater than 4, it is nothing but a D. True. Now whether weight is equal to an D, weight is 0. See here, weight is 0. No. False. Or weight plus next element. What is my weight? 0. Next element is 3. So 0 plus 3 is less than or equal to 4. True. Now it is OR operation. False or true is true, and it is AND operation. True and true is true. So what is promising is returning? It is returning true. So if it is returning true, I told you that two things I need to check, whether I got the solution or I have not got the solution. What is how to check that one? Whether the weight is equal to D. So weight is 0. So it is not equal to 4, means it is not a solution. So I need to continue. So when I need to continue, first I need to finish all the left branches and then call the right branch. You know that while explaining the merge sort, quick sort, I told you how it will be implemented using an stack. So first all the left call will be finished, then right call. So now according to this, if I'll check what will be there in the stack initially. Sum of subset of 008, then 117, then 244, then this one, and then 107, then 234, and then 204, and then 340, then 300. So that is how that will be pushed on to the stack. Now I will come to this one. So now call the left means 117. So 117 will be pushed on to the stack. So 117 will be and pushed on to the stack. You know that how we are getting that 117. So what is that in the algorithm, how we are calling the left branch? It is nothing but sum of subset of I plus 1. So initially it was 0, now it will become 1. Then weight was 0, 0 plus the next element is 1. So it is 1. So 1, 1, and total minus the first element. First element is 1, so total was 8. 8 minus 1 is 7. So that is how we got the 117. That is this one, 117. Now this will be pushed on to the stack. So 117 will be pushed on to the stack. Now again I will call the sum of subset of the 117, and again I will call if promising. When I will call the if promising, it will check whether it is true or false. Yes, if it is true means continue. When I want to continue, I will check whether it is a solution. That is weight is equal to D. No, it is not a solution. Again, which one has to be called? Again, left only has to be called. So initially all the left call has to be finished. So what is the next I am calling? 2, 4, 4. It is 4. So when I am calling this one, solution of the 2 I will make it, because it is a left call, no? So solution of the 2 should become 1, and I am calling a sum of subset of I plus 1. So I plus 1 will become 1 plus 1, 2, and weight plus the next element. So 1 plus what is the next element? 3. So 1 plus 3 is 4, and total is 7 minus 3. 7 minus 3 is 4. Therefore that is same thing, no? I explained you, no? So it is 7 minus 3, 4, and it is 1 plus 3, 4. This is 4 actually, 244. Here I have written correctly. So it is 244, sum of subset of 244. So that 244 will be pushed on to the stack. So sum of subset of 7 was pushed. Now again left call. So 244 will be pushed. When I am calling 244, again I will calling the promise. When I am calling the promise, it will return true. Now when I am checking weight is equal to D, yes, my weight is 4. So 4 is equal to 4 means I got the solution. When I am getting the solution, what I have to do? I need to print the result. So print the result means, so I will go for a solution of this one. Solution of, where is I am printing the result? The solution of 1. So solution of 1 I have made it as a 1. So print 1. Now J value is become 2. Solution of 2 is also I have made it as an 1. Therefore print the 3. Here no, whenever I am going to call the left branch, we are making the solution. See here, solution of 1 I have made 1, and the solution of 2 also I have made as an 1. So print both the 1 and print the 3. So 1 and 3 will be printed. Okay. Now once this 244 is over, pop it out. That means once this we got the solution and we have printed the result, you pop it out from the stack. So pop 244 from the stack, and now what is there on a top of the stack? 1117 is there. 117 is there on a top of the stack. Now what call I have to do? Now I have to do the right call. When I wanted to do the right call, what is pushed on to the stack now? So I value has to be incremented. So now I will become 2 and weight will be same, that is 2 1, and this is 7 minus 3 4. So it is 214. So here it is sum of subset of 214. So what is the next element you are pushing on to the stack? It is nothing but a 214. Sum of subset of 214 has to be pushed on to, I have not written it. Where it has to be written? So after popping this one, what has to be pushed on to the stack? 214. That is sum of subset of 214 has to be. So after popping this one, which I have to push onto the stack, it is 214 has to be pushed onto the stack. Now when I am calling the promising, it is returning false. False means what? Don't continue. Why? Here you can see here. No, it will become a dead vertex. So now all left call is over, right call is over. Now I have to pop this also, because now for 117 there both are over, left is over, right is over. So I need to pop the 117 also. So first initially pop the 214 and then pop the 117. So what will be on a top of the stack now? The 008 will be on a top of the stack. So you can see this, both I have popped it out. Now 008 is on a top of the stack. Now which has to be pushed on to the stack? That is the right call. Right call means which one? That is an 107 has to be, that is this one. This has to be pushed, right call, right call, this has to be pushed. So whenever you will be making a right call, you make the solution of the I will be equal to the 0. You remember this point. Whenever you are making an right call, see here, solution of 1 I have made it as a 0. Whenever you are making, here also we have made the right call, no? So solution of the 2 I have made it as an 0. Okay. So whenever right call is made, this will become 0. Now 107 has to be pushed on to the stack. Then after that one, again it will work in the same flow. Then which one will be pushed on to the stack? 204 will be pushed. Then 340 will be pushed. Okay. 107 has to be pushed. After that 234 has to be pushed. Now there is no right left, so this will become dead vertex. So pop the 234 out, and then for this top of the stack you will be having 107. For that make the right call, that is 204 is pushed on to the stack. Then make the left call for that, that is 340 pushed on to the stack. Now this is the solution, print the result. Again you make the right call, that is 300 will be pushed on to the stack. Now further there is no solution, so pop it out of the stack. Now this will be popped out, and then this will be popped out, finally this will be popped out. So that is how the tracing will be. But usually in the exam they won't ask you such type of the tracing, just I am explaining. See here, all the things will be popped out at the end. This I am just explaining for your purpose to understand how internally this sum of subset problem works when there is a recursive call. But tracing means only you need to write this solution space tree, right? Only this much, there is more than enough. No need of writing the tracing along with the stack. This is not required, only you write down this particular solution space tree. So that is the tracing for an sum of subset problem. I think this is your lab program also, sum of subset. So when I will come to that particular lab program, once again I will not going to explain this how it is working along with the stack, because it was almost same thing only. Okay. So when I will come to the lab, just I will explain whatever extra things are there. But how the tracing will be done, okay, that is already explained here. Once again I will not repeat the same concept. I think same concept only you are using it in the lab also, lab program also. Okay, thank you. You solve few more problems on this. Thank you.